Good morning, it's Engineer Heather there. I warmly welcome all of you guys on my channel Complex World. So today we are going to learn about the bipolar junction transistor BJT. In this lecture, we will learn the basic definition, concept, construction of bipolar junction transistor, that what are the bipolar junction transistors and why and where we use the bipolar junction transistor and what are the applications of bipolar junction transistors. So we will learn the basic concept and we will learn about the construction of bipolar junction transistor, and we will learn about the regions, in how many regions the bipolar junction transistor operate. So in this lecture we will learn about these 3 points. Okay, let's start our lecture by starting with the definition of a bipolar junction transistor, that what is the bipolar junction transistor and why we use the bipolar junction transistor. So the basic definition of a bipolar junction transistor is that the bipolar junction transistor is a semiconductor device which can be used for switching or an amplification. So we use the bipolar junction transistor for 2 purposes. First one is switching and the second one is for amplification. So these are the 2 basic terms where we use the bipolar junction transistor. So always remember that the bipolar junction transistor are the semiconductor devices that can be used for switching and amplification purpose. Okay, how many terminals a bipolar transistor have? A transistor have a 3 terminals. The first one is known as base. The second terminal is collector, C, and the third one is emitter, E. So a transistor has 3 terminals, base, collector and emitter. Unlike other semiconductor devices which are made up from 2 pieces of semiconductor material to form a p-n junction, as we all know that we all familiar with the diodes, that we have p-n junctions. So unlike other semiconductor devices which are made up of 2 pieces of semiconductor material to form a p-n junction, so we use mostly the silicon or germanium. These are the 2 semiconductor materials which we use. Okay, now how this, transistors are made by using this p-n junction. The bipolar transistor use 1 or more layer of a semiconductor to produce a device. So how 1 or more layers are used to create this transistor element? If we join 2 single diodes, if we join 2 diodes back to back, this will give us 2 p-n junctions. Let's say we have 2 p-n junctions, p-n and p-n. This is the first one and this one is the second one. If we join these 2 signal diodes back to back, this will give us 2 p-n junctions. Connected them together in a series, which would be share a common or positive or a negative terminal. If we connect them in a series, they will share their terminals positive or negative. The fusion of these 2 diodes produce a 3-layer 2 junction 3 terminal device which is known as bipolar junction transistor. Okay, so we have 2 p-n junctions which are connected together in a series, and the connection of these 2 diodes back to back, this will give us a 3-layer 2 junction 3 terminal device which is known as the bipolar junction transistor. So device is just like this. We have emitter, base and collector. This is the bipolar junction transistors. Okay, this bipolar junction transistor has an ability to operate within 3 different regions. So what are the 3 different regions of operation of a bipolar junction transistor? The first one is known as the active region. The second one is saturation or saturated region, and the third one is cutoff. Okay, what is the active region? In the active region, when the diode is operating in an active region, it operates as an amplifier, and in this case collector current is equal to beta IB. This is the relation for an active region, and in active region the transistor work as an amplifier. The second one is the saturation region, in which the diode is fully on, and in this case IC equals to ISAT. Okay, now the third one is a cutoff region. In the cutoff region, the transistor is fully off, and in that case collector current equals to 0. So these are the three regions in which the bipolar junction transistor work. The first one is an active region, saturation, and the cutoff. In active region, the diodes operates as an amplifier, and IC equals to beta IB. In saturation, fully on, IC equals to ISAT, and cutoff region fully off, IC equals to 0. So these are the region of operation. Bipolar junction transistors are the current regulating device. These are the current regulating device. What is the current regulating device? Because they control the amount of the current that is flowing through the ammeter to the collector. These are the current regulating device. Why these are the current regulating device? Because they control the amount of the current flowing through them from ammeter to the collector. So these are current regulating device. Okay, now we have two type of bipolar junction transistor. The first one is PNP and the second one is NPN. Okay, so we have two types of bipolar junction transistor construction here. The first one is PNP and the second one is NPN. Okay, what their circuit symbol represent be like? What is the difference between PNP and NPN, and what is the difference between the circle representation of these two different semiconductor transistors, PNP and NPN? Okay, let me design these two symbols for you. This is the base and the arrow is going outside. This is a circle representation symbol for PNP and this one is for NPN. Okay, what are these arrows and what are these arrows are representing? The construction and symbol for both PNP and NPN with arrow in the circuit symbol. These are the arrows in the circuit symbol which are showing the direction of the conventional current flowing between the base terminal and emitter terminal. They show the direction of a conventional current which is flowing between the base terminal and emitter terminal. These arrow symbols are representing this one. Okay, after this we have the configurations for a bipolar junction transistor. Basic configurations. The first one is common base configuration. The second one is common emitter configuration. And the third one is common collector. Okay, what is the common base configuration? The common base configuration is such type of configuration in which the base is a common and it has voltage gain, V gain. It has a voltage gain, but the common base configuration we don't have a current gain. We don't have a current gain in a common base config. We have a voltage gain. What is a common emitter configuration? In common emitter configuration, the emitter is common And when the in common emitter configuration, the emitter is common and it has current gain and voltage gain. It has both current and voltage gain, but in a common base configuration we just have a voltage gain, we don't have a current gain in a common base configuration. So what is common collector configuration? A configuration in which the collector is common, and a common collector configuration has current gain. It has current gain but no voltage gain. We don't have a voltage gain. So these are the basic configuration of a bipolar junction transistor: common base, common emitter, and common collector. Common base has a voltage gain, common emitter has voltage and current gain, and common collector has a current gain. Now what are the characteristics of these configurations of a bipolar junction transistor? So first of all, we have input impedance. The common base has a low input impedance, common emitter has medium, and the common collector has high input impedance. Now come to the output impedance. It has, the common base has very high output impedance, the common emitter has high output impedance, and the common collector has low output impedance. The next one is the phase shift. Common base has 0° phase shift. This one has 180°, and common collector also have a 0° phase shift. Now come to the voltage gain. It has high voltage gain, medium, and low, because in common base configuration we have a voltage gain but no current. Okay, now come to the current gain. As we know that the common collector configuration has a current gain which is very high and no voltage gain. So in common emitter it has a medium. Okay, what is the power gain? Common base has a low, common emitter has very high power gain, and common collector has a medium power gain. So these are the characteristics of configurations of a bipolar junction transistors. Voltage gain, common base has high voltage gain, and because it has voltage gain but no current gain. In a current gain, common collector has a current gain but no voltage gain. So power gain will be low for this case, and power is medium for common collector case, and very high power in a common emitter configuration.